The speed time graph is given for a motion of the car. Figure 1.1 shows a speed time graph for a motion of a car from a moment the order is given. So the moment order is given, the car was traveling with 18 meter per second. But look, this is a point where the instructor gave the order. But you can see for some time, like about zero point 0.9 second or till 0.9 second, so you can see first it is traveling at 18 meter per second until 0.9 second it continued to move with 18 meter per second and then it stopped. So what is the reason why in this point, even though the instructor gave the order to stop, but the driver did not stop? So what is the reason for that? The reason is the reaction time. Like this is what happened with us, like as a human being, we take time to react to the instruction. It's not like if someone will say stop the car and immediately you will stop the car. What will happen if someone will say stop the car? You will take time to react to the instruction, and then it will also take time to uh, press the brake pedal. So that is the reason why, even though the instructor give order to stop the car, but the driver or the student did not stop. What is the reason for that? Because of reaction time. So the order to stop the car is given when time is equals to 0. State the speed of the car at this point. So what about the speed of the car when time is equals to 0? So it is 18 meter per second. So at this point, the car was traveling with 18 meter per second. How to know? Because from 0 to 10, there are 10 boxes. So if 10 boxes are there representing 10, it means each box is representing 1. So suggest why the car continued to travel for 0.9 second. What is the reason why, even though the instructor ordered the student to stop the car, but student did not stop. The student did not apply the brake. So what is the reason? Because a student will take time to react. So student took time to react. So as he took time to react, he did not press the brake pedal or a brake pad. That's why the car did not stop. So what is the reason why the car continued to travel at this speed for 0.9 second? Because the student took time to react, or the reaction type of a student is responsible that it does not stop immediately. Calculate the deceleration of a car from 0.9 second to 4 second. So from 0.9 second to 4 second, we want a deceleration. At 0.9, it was traveling at 18 meter per second, and 4, it is traveling at 0 meter per second. And the time interval, the time difference from 0.9 to 4, that is 3.1. So to calculate the acceleration or deceleration, it is having a same formula, that acceleration or deceleration is change in velocity divided by time. The final velocity is 0, initial velocity is 18, and how much time it took? It started from 0.9 and stop at 4, so it took about 3.1 second. So it will be minus 18 divided by 3.1. So when minus 18 divided by 3.1, we'll get the answer as minus 5.8 meter per second square. So negative sign shows that it is decelerating or it is slowing down. If you get that negative expression, that means it is deceleration. So negative 5.8 shows the deceleration of the car. And the last, the total distance traveled by the car from 0 second. So total distance, whenever there is a speed time graph, we use the area under the graph. So we can use a trapezium, or we can divide into a rectangle and a triangle. So till this point, it is a rectangle, and here it is a triangle. So we have to find the area of a rectangle. How to find area of the rectangle? It is length. So length of the rectangle start from 0 till zero point 0.9. So this is 0.9 and the height is 18. So this will be 0.9 times 18. So this will give us the distance travel or area under the rectangle. So zero point 0.9 multiplied by 18, which is 16.2. So 16.2 is a distance travel in this region. What about the distance travel in the triangle? So that is half base multiplied by height. So 1 by 2. What about the base? It is starting from 0 0.9 and it is ending at 4. So the total base is 3.1. And what about the height? That is 18. So it will be 18 multiplied by 3.1 divided by 2. So that is equals to 27.9. So 27.9 is the area of the triangle and 16.2 is the area of the rectangle. So when we sum them, so when I add 16.2 plus 27.9, the final will be 44.1 meter, or I can say 44. In marking scheme, normally the answers are rounded off, but if you write 44.1, that is also the right answer. Is it clear till this point that how we work out the distance travel? Anyone having a question or a doubt?
Sir, what will be the final answer?
The final answer, we will add them because this is 16.2 for the rectangle and 27.9 is for triangle. So we add them 16.2 plus 27.9. So the final answer is 44.1 meter. That is the distance traveled by this car. Yes, we can also use a trapezium. We can use sum of the half sum of the parallel side into height. So in that case, you will also get the same result. It won't make difference as if you use a trapezium, these are the two parallel sides and the distance between the parallel side, that's called h. So the formula which we use for trapezium, it is half sum of the parallel side into height. So the first parallel side example, this is A. So it's starting from 0 and 0 0.9. So A is 0 0.9 plus B starting from 0 till 4 divided by 2 and multiplied by what? Multiplied by h. H is the height, the distance between the two parallel sides. So that is 18. So this will be multiplied by 18. So 0 0.9 plus 4, that will be 4.9 divided by 2 will give us 2.45 and that is multiplied by 18. When you solve, you'll also get the same answer. So it is up to you what you find it easy way, easy method. Apply that and get the final answer. In A2 suggests why the car continued at this speed, because what happened, like if there is a car and say a driver and the instructor, so when the instructor give the driver order that stop the car, so this driver will take time to react. Like this is a what happened as a human being, we have a reaction time, we take time to react to the order. Even you want to stop anything, like example you're driving a car and you see the signal and you think I should stop, so when you're thinking you will take time to react, so that is called a reaction time. So same thing, when the instructor order this driver to stop the car, the driver will not immediately react to the instruction, he will take time to react, and when he's taking time to react, the car is continue to move with that constant speed. So in this part, because the driver is taking time to react, that's why the car continue to move. And this is a point where the driver act like applies the brake, that's why the car slow down. Then describe and explain the danger to a driver not wearing a seat belt during a sudden stop. So This is a general question. It's not directly related to what you use of physics. You can just mention that if he's not using the seat belt, what might the possibility is that he might hit the windscreen or a dashboard and can cause a greater damage to, or can cause a serious injury, because if a driver applies a brake and there is no seat belt, so he will move forward because of its inertia, and he will hit the dashboard or a windscreen and can cause fatal or serious injury. So if he is not wearing a seat belt, what will happen? The driver will move forward because of his inertia. Inertia means property of an object to resist the change in state. Because the car, when you are sitting inside a car and a car is traveling at a 120 kilometer per hour, so your speed is also 120 kilometer per hour because you are inside the car. So when you apply the brake, the car stops, but because you are also in a state of motion with the car, so you continue to move because of your inertia, and as you move because of inertia, you will hit the windscreen. Is it clear? Question one. So this was question one. Now question two. Sorry. Figure 2.1 shows a hammer which is used to drive the nail. So the hammer head and the nail is given and the wood is there. The mass of the hammer head is 0.15 and the speed of the hammer head is, as it hits the nail, it is 8 meter per second. The time for which the hammer head is in contact, that is 0.0015 second. After hammerhead the hammerhead stop after hitting the nail. Calculate the change in momentum. So what is the formula for change in momentum? The change in momentum is final momentum minus initial momentum. The difference in momentum is called change in momentum, or we also call impulse. And there are two formulas to get the impulse. Impulse is force multiplied by time, or impulse or change in momentum is the final momentum minus initial momentum. So what about the final momentum? As you can see, they mention the hammerhead stopped. So when this hammerhead is hit, its speed is zero. So if its speed is zero, what about the momentum? Because the moment, so what will be the final momentum? Momentum is a product of mass and velocity. So mass multiplied by velocity will get the momentum. So mass is 0.15, and what about the velocity? The speed, that is 8. Sorry, speed is 0, the final, because it stopped. So the final momentum will be 0 kilogram meter per second. What about the initial momentum when the hammer head was moving? So initial momentum, again it will be the product of mass and velocity. What about the mass? That is 0.15, the hammer head only, and multiplied by speed which it was moving, it is 8. So 0.15 multiplied by 8. So that is equals to 1.2. So initial is 1.2 and final is 0. So what, we cannot use this formula impulse is force into time because we don't know the force. So we can use this formula which final momentum minus initial. So the final is 0. So impulse is equals to final, which is 0, minus initial was 1.2. So 0 minus 1.2, I'll get minus 1.2 Newton second, because impulse or change in momentum can be Newton second or it can be kilogram meter per second. It won't make difference to the answer. Is it clear? Part A. Now the second part, state the impulse given to the nail. So whenever two objects collide, they will always have the same impulse. So if the impulse of the hammer was 1.2 Newton second or 1.2 kilogram meter per second, what will be the impulse of the nail? That will be 1.2 Newton second, because whenever two objects collide with each other, they will have the same impulse, same change in momentum. So for part B, we don't have to calculate anything. And remember, the direction will be opposite. So if this impulse was minus 1.2 Newton second, so this impulse will be 1.2 Newton second. So when two objects collide with each other, they will have the same impulse but in opposite direction. So if one is negative impulse, the other one will be positive impulse. Then calculate the average force between the hammer and the nail. So we have the impulse. So impulse is equals to force multiplied by time. The impulse is given 1.2, force we don't know, and for time for which they are in contact, that is 0.0015. So 0.0015, that is multiplied, other side it will divide. So 1.2 divided by 0.0015, that will give us the force. So when we substitute the value, we'll get the force which exerted on the nail, which is equals to 800 Newton. So the force here is equals to 800 Newton. In question 3a, on figure, draw a graph for force against a load for a spring which obey a Hooke's law. When spring obeys a Hooke's law, force and extension are directly proportional. So there should be a straight line. We increase the load, the extension will also increase. State the word used to describe the energy stored in the spring that has been stretched or compressed. So the term which we use, the energy stored due to deformation, change in length, shape or size, we call that as elastic strain energy. So here we can say that is strain energy, or you can say elastic strain energy. So whenever object compress, stretch, deform, changes shape, length or size, we call that as elastic strain energy. Then in part B, figure 3.2 shows a model train which is traveling at a speed of v and approaches a buffer. Like a spring system is there, which we call buffer. The mass of the train is 2.5 kilogram. So when this train is moving, which form of energy the train will have? It will have kinetic. But when the train collide with a buffer, the spring will compress. So all of the kinetic energy transferred into elastic strain energy. So all of the kinetic energy converted into elastic strain energy. But we assume here there is no other form of energy, like all the kinetic which was there converted into elastic strain. So as it is stopped by compressing a spring in the buffer, after the train stopped, the energy stored in the spring is 0.48. So if the elastic strain energy, the energy stored in the spring is 0.48 joules, how much is the kinetic energy before the train was moving or collided? So it will also have 0.48 joules, because it is like an energy transformation that a moving train, when it hits the buffer, the kinetic energy of the train convert into elastic strain energy. And then we need an initial speed. So if we know the kinetic energy, how to get the speed? The formula is kinetic energy is equals to half 0.1 mv square. That's a formula which relate the mass, speed and kinetic energy. The kinetic energy is 0.48, 0.5. The mass of the train, the model train, is 2.5 kg. So 2.5 multiplied by v square. 0.5 multiplied by 2.5, it will be 1.25. So 0.48 is equals to 1.25 into v square. 1.25 is multiplied, other side it will divide. So 0.48 divided by 1.25 will be v square. So 0.48 divided by 1.25, That will give us 0.384. So 0.384 or 0.384 is the answer for v square. But we don't need v square, we need v, the speed only. So to remove the square, we take under root both sides. So when we take square root or under root both sides, the square will cancel with root. So we are left with v here. And when we take under root of 0.384, this will give us 0.62 meter per second. So the speed is 0.62 meter per second. Is it clear? Yes, Mina?
Sir, I didn't understand like why the kinetic energy is the same as the potential energy.
Is same as the elastic.
Sorry, it's same as the elastic, yes.
Yeah. Because as they mention here that the train is stopped by compressing a spring in the buffer. So train was moving. If anything is moving, it will have kinetic. And how it is stopped? How this train is stopped completely? This train is stopped completely by compressing a spring. So example, if I say I have a ball or a sphere which is having a kinetic energy of 10 joule and there is a spring. So when ball hits the spring compresses and the ball stops. So if the ball stops, it means ball kinetic energy is transformed into strain energy. So how much energy stored in the spring? The spring will have elastic strain energy, and that is also 10 joules. So when moving object hit the surface, if it compress the surface, it means the kinetic energy transformed into elastic strain energy. Then the source of solar energy is the sun. Solar energy means like the heat and light energy from the sun. Take the box next to resources from which sun is also source of energy. Like example, coal. How coal is formed? So what happened? Like first, the energy from the sun is absorbed by the plants. So these plants on the surface of the earth, they absorb energy, the heat and the light energy. And when these plants die, so if they are covered with a layer of a sand under high pressure in the limited supply of oxygen, what will happen? This will turn into coal. So basically the energy which is present in a coal is from the sun only. That's why we take coal. Geothermal, what is the geothermal energy? Geothermal energy means energy from the heat of the earth. So because inside the earth there are nuclear reactions which are happening, this crust mantle and core inside. So why the core is producing that energy? Because there are some reactions inside, nuclear reactions, and that release that energy in the form of heat. So this energy which we get from the earth, we call that as geo. Geo means related to earth, and thermal means heat. So geothermal is not derived from a sun. Sun has nothing to do with the geothermal energy. That's why geothermal is not derived from the sun. Hydroelectric means hydro is a term used for water. It's related to a water cycle, and water cycle is actually originate from the sun only. What happened when the large bodies of the water absorb heat energy from the sun? So this water will evaporate, and as a result, when this water will evaporate, it will form clouds. And when these clouds move from one region to another, and normally it rain at a higher altitude. So when it rain at a higher altitude, the water start to flow, and we store this water behind the dam. We block the stop the flow of the water behind the dam, and the level of the water will increase or rise. So as the level of the water will rise, this energy, the potential energy of this water, we can use it to generate electricity. So what we call that as hydroelectric. So hydroelectric is originated from the sun. If there was no sun, there will be no evaporation. No evaporation means no rain, and if there is no rain, we don't have water to store. So that's why it is also originated from sun. What about nuclear energy? Nuclear energy is not like nuclear energy is when lighter nuclei join to form heavy, or heavy nucleus break down to form lighter. So it does not depends on even we have sun or we don't have sun, nuclear energy can be released. And what about the wind energy? The source of the wind energy is again sun is there, because what happened when the sun is providing heat energy to both land and water. So because the proportion of the land is so small, it cannot absorb too much heat energy. So the air which is above the land will become hot more quickly as compared to air above the sea. So when this air particle above the land will become hot, the hot energetic molecules, they have less volume, they have a large volume, so less density, so it will rise. As a result, when the hot energetic molecule rise, cold molecules from the air will move from the sea, move toward the land, and that cause a wind. How sun is producing energy? Sun is producing energy by a nuclear reaction, but the question is, tick the box next to those resources from which sun is also a source of energy. So sun is getting energy due to nuclear reaction, but nuclear reaction does not get energy because of sun. So we have to work out which one are originated from the sun or released due to the sun. On the surface of the sun, what happened? Lighter nuclei join to form a heavy, and that release energy. So on the sun, there is a nuclear reaction. So nuclear reaction on the sun produce energy, but sun is not producing a nuclear reaction. Like sun is not causing the nuclear reaction to occur. The atoms are there and they can undergo nuclear reaction. So it does not depend whether we have sun or no, nuclear reaction can occur, because it is like the nucleus join or nucleus breakdown to release the nuclear energy. Is it clear, this part?
Yes, sir.
Then figure 4.1 shows a solar water heater which is placed on a roof of a house, and cold water flow into the water in the copper tubes which are heated by a solar radiation. A hot water flows out. Basically, what is happening, like the copper which is painted black, so water is flowing, it is absorbing the heat energy, and it is coming out as a hot water. So cold water flow into a copper tube which are heated by solar radiation, and hot water flows out. Explain why the tubes are made up of copper and painted black. What is the reason? Why copper is a metal and it is a good conductor of heat, and why it is painted black? Because dull and black surfaces or black paint can absorb more energy. So because dull and dark surfaces are good absorbers, so it can absorb greater amount of energy. That's why it is painted black. If you don't want it to absorb energy, then it should be shiny. The next part, in 5 seconds, 0.01 0.19 kilogram of water flow out the tube. The temperature of a water increases from 20 to 72. The specific heat capacity is 4200. Calculate the thermal energy gain in 5 seconds. The formula which relate the energy and specific heat E is equal, like C is equals to E divided by m delta T. So C is equals to E the energy divided by mass into delta T, T2 minus T1. So specific heat is how much? The specific heat is given 4200. E is the energy which we are finding. M is the mass which is 0.019, and temperature change, the final, it is always greater minus smaller. So it is 72 minus 20, which is 52. So this whole is divided. So 4200 is equals to E divided by 0.019 times 52. This whole is divided, other side multiplied. So 4200 multiplied by 0.019 multiplied by 52, we will get E the energy. So when we multiply all the factors, this energy will come out as 4100 joules. But again, that will be the rounded off answer. Why 0.019? Because that is the mass of the water which flow. The M is the mass of the water which absorb energy. So how much mass of the water absorb energy in the question? That is 0.019. That's why we took 0.019. So 4100, that's again a rounded off answer, will be there in joules. Is it clear, this question?
Yes, clear, sir.
Then efficiency of a solar panel is 70%. Calculate the power of the solar panel, calculate the power of solar radiation incident. What is the formula for efficiency? Efficiency is equals to useful power output divided by total power input multiplied by 100. So we need the power input efficiency 70%, that is given. What is the useful power? Because what happened? The solar radiation input, that is a power input, and it causes the water to become warm, so that will be power output. So how to get the power output? We already have the energy. In the last part we calculated the energy, which was 4100. So that is the energy here, 4100 joules. And how much time it took to absorb this energy? So power is equals to energy divided by time. So 4100 divided by time is 5 seconds. So this will give us the power output. So 4100 divided by 5, which is 820. So power output is 820, and input we are finding, like how much is coming from the sun, into 100. When we simplify, power input will move there and 70 in division. So power input is equals to 820 divided by 70 into 100. So 820 multiplied by 100 divided by 70. Yes, Mina? Which is,
Uh,
yes.
Sir, I'm confused. How, from where we bring 820?
From where we'll bring 820, as you can see in the previous part, that the thermal energy which it is absorbing, because what happened, like there are copper pipes, so power is coming from the sun, that is the input power, and the water become hot. So how the water become hot? By absorbing the energy. So what is the power absorbed or energy absorbed in every second? So that is power output is energy absorbed by the water divided by time. Energy absorbed by the water is 4100, and how much time it was taking to absorb this energy? It was taking 5 seconds. From that is how we got 820 watt. So energy absorbed by the water divided by
Sir,
time. Yes.
it is 4200, not 4100. So when we
4000.
divide it by 5,
No.
equal 840.
The thermal energy. This answer. I'm talking about this answer was
Mm.
4100. When
Oh,
we